और इफ यू आर नॉट हैविंग इनफ कॉन्फिडेंस, तो क्या होता है, आदमी अटेम्प्ट ही नहीं करता. एंड इफ यू डू नॉट अटेम्प्ट, देन द रीजन इज दैट द failure is not because you are not understanding. Failure is because you are not attempting. तो अटेम्प्ट करना है. एक बार करो, 2 बार करो, 4 बार करो, 10 बार करो. जब तक सफल नहीं होते तब तक करो. फिर एक दिन असफलता ही आपसे पीछा छुड़ाएगी. बोलेगे नहीं यार, इसके साथ रहने से कुछ फायदा नहीं. बराबर है ना?
यस सर.
या okay. So any queries if you have, you can ask me, because we are at as per my clock it is 7:27, so we can discuss 3 to 4 minutes with whatever difficulties that you might have faced. Yeah.
सर
Hello.
ई टैब
Yes.
सर ई टैब में स्टेयर का मॉडलिंग करते हैं तो
Okay.
उस पर लाइव लोड कितना देंगे सर
स्टेयर के लिए?
हाँ.
See, that depends whether that stair is for residential building or commercial building or public building. If you follow IS 875 part 2, which is for
sir.
live load, then the categories are given, and in that for residential category, staircase loading, I am talking about live load. So live load is to be considered as 3 kilonewton for residential purpose, and if you are having a commercial premises or the structure, then live load is considered as 5.
Okay sir.
So that you can go through that 875 codal provisions, but look into part 2, because part 1 is dealing with dead load, part 2 is dealing with live load.
Okay.
Clear?
Yes sir.
Okay. ये इतना क्यों डिफिकल्ट लगा?
नहीं सर, मैं अभी वो निकाला, नोट निकाला, डीबीआर करके एक प्रैक्टिकल फाइल, तो उसमें लिखा हुआ, तो मैं उसको पढ़ रहा हूँ, मैं बता रहा हूँ उसको.
अच्छा. वो डीबीआर हमने जो आपको दिया है वो पढ़ रहे हैं आप?
हाँ, उसको मैं कर रहा था. सर मैं आज G+7 का मेरा मॉडल कंप्लीट था. सुलेखा मैम से मैंने नंबर भी लिया था आपका, और क्या सेव नहीं किया था, लाइट कटा, बैटरी बैकअप था नहीं, पूरा फाइल ही सेव नहीं था, तो खत्म हो गया. फिर से मुझे बनाना पड़ा.
दैट इज वेरी नाइस. See, आपका फाइल इरेज हो गया. दैट इज अ वेरी नाइस थिंग, बिकॉज नाउ यू विल डू इट अगेन. ओके, समझ में आ रहा है ना? हाउ द या सी इट इज अ सॉर्ट ऑफ एटीट्यूड. जो लोगों को खराब लगता है ना, उससे मैं खुश होता हूँ, क्योंकि नाउ यू आर ऑन द राइट ट्रैक. सो इफ यू आर फेलिंग, देन यू आर ऑन द राइट ट्रैक, because now your attempts will be increased, and that is a sign.
एक चीज और है सर, लोड्स ऑन स्टेयर केस कैप है सर. हम लोग स्टेयर कैप के मम्टी के ऊपर ओवर टैंक वाटर टैंक नहीं, क्या करते उसको नहीं बना सकते हैं, डिजाइन नहीं कर सकते. सर बगल में अगर वाटर टैंक बनाते तो उसका लोड कितना लेना होगा?
वो तो see, if you follow IS 875 part 2 part 1, it will deal with wet density of water, that is 10 kilonewton per square meter.
इसमें ये चीज
density per cubic meter.
इसमें
so you can calculate total weight of water, and then divide it by height. That will give you weight per square meter.
यस सर. एक चीज
कैलकुलेशन प्रोसेस विल बी सेम.
हाँ सर, ये एक चीज और था, ये बोल रहा है, वी आर नॉट मॉडलिंग द स्टेयर केस इन ई टैब, सो वी आर ट्रांसफरिंग लोड ऑफ स्टेयर केस ऑन मिड लैंडिंग एंड फ्लोर बीम एज यूडीएल. द कैलकुलेशन एज बिलो. स्पैन ऑफ ए स्टेयर केस 4.29 मीटर लिया हुआ है सर इसमें.
राइट.
तो सर वो इसका डिस्टेंस जो बीम का डिस्टेंस वही लिया हुआ ना जो हम डिजाइन किए उस टाइम।
राइट। तो उससे नहीं नहीं, उससे क्या फर्क पड़ेगा? लोडिंग में क्या फर्क पड़ेगा? कुछ नहीं, थोड़ा बहुत अप्रोक्सीमेशन हो जाएगा। इंस्टेड ऑफ दैट inclined loading, yeah, you are applying it horizontal loading. So see, there will be a little bit difference, but उससे क्या फर्क पड़ता है? You are not designing. See, if you are getting load on column something around say 1000 kilonewton, you are not designing the column only for 1000. तो actually वो ज्यादा आ जाता है, so that is tolerable.
ओके सर।
See, basically nothing is exact. You cannot find exact analysis. You cannot go for exact analysis. So what, as a structure engineer, what we are trying to find out, what is the probable maximum loading, and based on that we are designing the element for that maximum. So anything less than that will be always taken care. And as you are designing for maximum, there is no chance for that one can say that your design is a little bit designed to higher load, but that is okay because you want safe. Barabar?
यस सर।
See, this is just a thought process. मान लो आपको किसी गांव जाना है और गांव को जाने, वहां रहने और वापस आपके घर पे आने के लिए यू नीड समथिंग अराउंड 5000 रुपीज। तो क्या एग्जैक्टली आप 5000 ही लेके जाते हो?
नहीं
आप
सर।
जेब में 7.5 लेके जाते हो ना?
यस सर।
So it's like that. If you're knowing that the loading on the column or probable maximum loading on the column is 1000 kilonewton, you are designing for 1100 kilonewton. So that is on the safer side. तो उसमें
यस।
थोड़ा इधर उधर हो गया तो कुछ फर्क नहीं पड़ता है ना?
नहीं सर।
So that is the approach. And that's why I always say that in civil engineering, nothing is exact. We are near to the exact. How much near? Nobody knows. You may be near by 5%, I may be near by 7%, someone else may be near by 10%. But he is near to the exact and on the higher side, right? So if your 100 kilonewton is the calculate it, might calculate it as a 110, or someone third person might calculate it as 115. But all three people are correct because nobody is less than 100. Everybody is above 100. Are you
यस
getting
सर।
it? Yeah. So if your answer does not match with my answer, that does not mean that you are wrong. Because I am also not finding the exact value, and you are not also going to find exact value. We are close to exact and on higher side, not on lower side. Okay.
ओके सर।
तो बाकी अभी छोटे मोटे क्वेश्चन तो दिमाग से निकल जाएंगे. See, that is what the total approach every structure engineer has in his mind. तो अगर अगर मान लो कि by just looking at the structure, if I can judge that this column may be subjected to 1000 kilonewton at ground floor, then without going for any analysis, I may design it for 1300 kilonewton. So I will say that I am plus 300. So don't worry about whether it is 1100 or 1200. I am taking care that it is not more than 1300. And that's why some people give you immediate designs, while someone else, maybe youngster, here he will go on calculating, he will go on making the model, go on calculating the analysis results, then finding out bending moment, shear force, etc. And while people like me who are more experienced, they will not do all these things. They will say that the answer may be something around 1000 kilonewton axial load, and say maybe about 35 kilonewton meter moment. So I will design the column for 10% higher, and I will say that this is your design. And you people feel that, "Arey, what intelligent this person is. Immediately he is giving you the answers. But the answers are always on higher side. Clear?
Yes, sir.
Okay. So a lot of people have joined. Let me welcome all of you. So Avinash, Hema, Ketan, Masroor Jahan, then Pritam,
Excuse me,
uh,
sir.
Sameer. Yeah. Yes.
बेस शेयर
Yeah.
हम कैसे कंसीडर करते हैं, बिल्डिंग के बेस ग्राउंड लेवल पे या फिर फाउंडेशन लेवल पे, या
See, whether it is at foundation level or whether it is at ground level, it is a base shear. It is calculated at the surface of the earth. So
ग्राउंड
you may,
लेवल से?
yeah, you may that it is at the ground. Actually, that base shear is later on distributed at every floor level, and that's why uh, even if the base shear, you may say that it is acting at footing level, or someone may say that it is acting at ground level. It makes no difference, because that is then it equivalently counteracted by the shear at every floor level. Clear?
फुटिंग को पहले हिट करेगा ना सर वो, अगर बेसमेंट ज्यादा है तो वो फुटिंग पहले देख रिएक्ट करेगी उसकी.
Okay, let me show you through the graph, because see, actually earthquake does not have any force on its own. पहले तो वो क्लियर कर लो आपके दिमाग में. Earthquake does not carry any force. The force are created in the structure because of the movement due to earthquake. ये बात समझ में आई या नहीं?
सर वो एक ही बार इसको हिट करता है, बट बाद में बिल्डिंग हिलते रहती है अपनी वजह से, अपनी फीचर्स की वजह से.
Earthquake is hitting the building and it is vibrating the base. That is all. Earthquake doesn't carry any force with him. Clear?
हाँ सर.
We'll see that. Don't worry about it. We'll see that. Uh, yes, the screen is shared to all of you. Yes, everybody can see the screen. Hello.
Yes, sir.
Okay.
Yes, sir.
So yeah, let me go to the PPT and then I will answer the question that is raised by Masroor. Okay. 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 The first I will answer the query and then quickly we will go to our data. Okay. Yes. Look at the figure. This is your building. And let's say this is your surface. So this is your earth surface, and somewhere here deep inside earth, the trigger is wrong. Now this will create wave. Okay. Now these waves are having energy and it is a dynamic effect, and because of that the movement having some acceleration, that is u double dot z of t. Okay. So because of this, Earth is moving. Is this much clear?
Yes, sir.
Hello. Now, the mass which is connected to Earth, that is plinth, will move with the same deformation as the Earth is moving. Okay, but the mass which is away from Earth's surface, which is at this height, or which is at this height, or which is at this height, it will not move as the ground is moving. So it will try to oppose. See, mass is the inertia, and inertia means which is accounted with resistance against the motion. You can go through the three fundamental laws stated by Newton, that mass, let's say substance, tries to maintain its position and it opposes the motion. If it is in motion, then it opposes to stop, right? So, and because of that, he has finally found that this force is equal to m times acceleration. Okay. Now here we are considering fx or fy. That's why I will say earthquake acceleration in horizontal direction. Okay, so this is u double dot g of t, which is the acceleration, and because of this acceleration, this mass does not want to move with this. Okay, that's why what is happening, if I simplify this like this structure, when subjected to this motion, it might move something like this. So you can see, and because of that, if the force is in this direction, this force is converted as equivalent force at every floor level with this equation. That is how we are finding out fx, which is acted at first floor, second, third, fourth, fifth, whatever number of floors. So this base shear, whatever we are calculating, is finally equilibrated by this V1, V2, and V3, right? So whether it is acting at base, whether it is acting at ground floor, or whether it is acting at footing level, so that has no meaning. You can say that base is moved with this force. Now this force is equivalently uh, distributed in the upper floor with three force, which is in this direction. This will be in this direction, and this will be in this direction. And the calculation of this V1, V2, and V3, or whatever these forces, is initially we have found it with the help of equivalent static load method, and now we are finding it with the help of dynamic analysis. Clear what? Hello?
Yes, sir.
Okay, now let us go and see where we were. So we have seen this, we have seen this. So this was our free vibration analysis. These were the mode shapes. This was what we are supposed to find out. The objectives, that modal mass, modal participation factor, story shear, base shear by this method, and scale factor. Now this scale factor I have not explained, that I will explain after the analysis. Okay.
Okay, sir.
Then we see that here the codal regulations, that code has given you how much should be the number of modes that you may consider, and this is about whether a regular, whether you can go for dynamic analysis, or you can restrict yourself to equivalent static load method. Now this is about how a modal mass is calculated. Now again, I will say that with if total seismic mass is say 100 kg, out of that, how much mass is getting activated in mode number K is designated as modal mass in mode K, and the calculation of that is with reference to this formula. Clear? Then participation factor. So modal participation factor. So how much is the participation factor of each mode? That is considered as PK. Then when you calculate modal mass, then you can calculate design lateral force at each floor in each mode with the help of this. Now you know PK, you know seismic weight at ith floor, you know phi IK, and you want to find out AK. Now this AK is found out with the help of pre-vibration analysis, AK. Then we have seen this limitation. So this was also, I will share you with a bit later. And now you can see we have completed this. So calculation of modal mass MK and modal participation factor PK. Now MK for mode number 1, MK for mode number 2, and MK, or you can say M1, M2, M3 are the modal masses that are getting activated when the system or when your structure will be subjected to mode number 1, mode number 2, and mode number 3. Similarly, PK is the participation factor, and that is this. So for P1, P2, or still you have some doubt in this? How?
Yes sir.
Am I audible?
सर म्यूट कर दिया था मैंने.
तो बात क्यों नहीं करते हैं? नहीं समझा. There is no software developed that can read in the minds who are at distance level from me. तो आपको बोलना पड़ेगा. Only then I can understand.
Yes, sir, understood.
Yeah. So you can find out MK and PK for respective modes. Now, why we are finding this for respective modes? Because the free vibration analysis has a property that when the system will be vibrated in that mode, it will offer less resistance. That means it will give you maximum deflection. Deformation, not if you know the maximum deformation, you're not worried about any deformation less than that. And you know that when this is maximum, that means any other deformation cannot be more than that. So when the system will vibrate in mode number 1, it will have these maximum deformations. Now all these deformations are, or every mass will reach its maximum deformation simultaneously. That simultaneously word is very important. That means let me show you that. See, if this is your structure having mass at 1, mass at 2, mass at 3, and mass at 4. Now when this mass attains its maximum, all these masses will attain their maximum, whether it is in positive direction, negative direction, that is different. So the maximum deformation for mode number 1, mass number 1, mass number 2, mass number 3, mass number 4, all these deformations will be exhibited simultaneously. That means ऐसा नहीं होगा कि when M4 is maximum, M3 is minimum. It will not be like that. all. So this is the maximum for M4, this is the maximum for M3, this is the maximum for M2, and this is the maximum for M1. So all these masses will reach their maximum or minimum or at equilibrium. नहीं थोड़ा clear नहीं हुआ. I can understand that. Okay, what is the thing that you have not understood? Yes.
Got it, sir.
Understood.
See, if this is my mode shape, that means in mode number 2, let's say this is in mode number 2. So it is having maximum in positive direction and it is having maximum in negative direction. This is also having maximum in negative direction and this is also having maximum in negative direction. That means when M4 will have positive, all other masses will have negative. Then all will have positive. So that's why it is a recognition that find out the maximum deformation of all masses with respect to each. Then you have to go for pre-vibration analysis because this is the property of structure. So if it is subjected to mode number 2, it will vibrate like this. If it is subjected to mode number 3, it will vibrate like this. If it is subjected to mode number 1, it will vibrate like this. So these are the shapes and these shapes are defined with these values. Clear?
Yes, sir.
So
Yes, sir.
that's why I can see that total mass mk in mode number 1 is considered as modal mass participated in vibration in first mode. Total mass getting participated in mode number 2 will be this mk, and in mode 3 this mk, and the same about pk. So in fact I can say that in another words I can say that these are the maximum deformations. These are related to maximum deformation. So anything less than this I'm not bothered because I'm going to design the entire structure for this maximum deformation. So with modal mass mk and participation factor pk, so that finally I have to find out the force, and that force is calculated with this mk and pk. How? That you can see. So now it's actually we are not interested in knowing this. We are interested in finding out the maximum forces, and that is that qik. So lateral load qik, that means I is the index for floor and k is index for mode. Okay, so if I want to find out qik, I must find out phi ik, I must find out pk, and I must find out wi. So everything we know, only ahk. Now this ahk, which is a design horizontal acceleration spectrum value, and that is calculated with respect to response spectrum. And that's why this method is called dynamic analysis using free vibration and response spectrum. You can see what is the title? Seismic force by response spectrum method. And this response spectrum is found out with that response spectra that has been given, and dynamic analysis is carried out. So you can see that dynamic analysis is carried out for free vibration. Clear?
Yes, sir.
So you can see that the lateral load QIK acting at ith floor in kth mode is this QIK. So I can find out QIK. That means I can find out Q11, Q12, Q21, Q31, Q41. Clear?
Yes, sir.
Yes, sir.
See, here I can find Q11. Then I can find Q21. Because everything is in mode number 1. So Q31 and Q41. Clear?
Yes, sir.
To 1K equal to 1, or you can say AH1, phi 11, P1, and W1. If I want to find out Q21, then I will go for this as AH1, phi 21, P1, and W2. Accordingly, you can find out all QIK, I equal to 1 to 4 and K equal to 1 to 3. So similarly for second, so this is for mode number 1. Similarly, I can find for mode number 2 and mode number 3. Yes?
Yes, sir.
Now all this, instead of finding individually, we are making a table so that nothing will be missed out. So what is that table? You can see first we'll see we have to find out T1. In equivalent static load method, we have found fundamental mode time period for fundamental first mode. So that was something 0.09 H over root D. Now dynamic analysis or free vibration analysis has given us T1 equal to 0.86. Now based on this 0.86 and using the response spectra, you can find out SA by G. And once you find SA by G, you can find out Z by 2 I by R SA by G. Same as equivalent static. Clear?
Yes, sir.
Yes, sir.
The only thing is that in equivalent static, you have assumed with some empirical formula, and here we have counted or we have analyzed dynamic analysis, that is eigenvector analysis or free vibration analysis. These are the two different names, and we have found out T1. Clear?
Yes, sir.
So 1 minute. फोन करतो बाबा मी तुला 9 वाजता. हो करतो. Yes. Okay, a little bit disturbance, but that is always good. तो अच्छा लगता है कि we are going on the right track. डिस्टर्बेंस तभी होता है जब आप सही रास्ता चुन लेते, नहीं तो नहीं होता है. क्लियर है?
यस सर.
यस सर.
अगर आप गलत रास्ते पे है ना, तो आपको टोकने वाला कोई नहीं आता. जब आप सही रास्ते पर है ना, तो लोग मिसगाइड करने आते हैं. तो अगर आपको डिस्टर्बेंस आया जिंदगी में, समझना यू आर ऑन द राइट ट्रैक. ओके, सो विद दिस we'll say T1 equal to 0.86, so SA by Z equal to 1.16, and based on that we have calculated AH1, and now here you can see AH1 is substituted, PK is substituted, and these are not substituted here because these will vary with floor, right? So
Yes,
floor
sir.
1, floor 2, floor 3, and floor 4. So WI will be different at every floor. So that's why it is given over here. Similarly, for mode number 2, you can see T2, that is calculated by free vibration analysis as 0.265, Based on that, you have calculated AH2, and based on that, you can see now this is not a QI1. Actually, it should be QI2 because it is for second mode. So make the correction in your PPT as QI2. This is QI1. This is QI2, and again this AS2 is calculated, PK is calculated, and these are not calculated. So they will have different magnitude at different floor. That's why it is given over here. Clear?
Yes, sir.
Then if I go to finally, you can see this is for mode 3. Again, T3 is calculated free vibration analysis, and based on that AS3 is calculated, and here you can see PK and AS3, and this is for this the QI3 into WI. Okay, now all these is shown in this tabular form. Okay.
Yes, sir.
So this is your free vibration analysis, and if you apply that QI1 formula over here and substitute WI equal to 4200 and this phi I1 as 0.441, you will get the value as 0.96. Clear?
Yes, sir.
Yes, sir.
You can see it over here. So if I substitute QI1 and WI for floor number 1 or first floor and multiply it with this, the answer that I am getting is written over here 96. Clear?
Yes, sir.
Similarly, this phi I1 and WI are the two different things. Then again PK and AH1. So you can get 155.9. Then similarly 196.8, and this for roof 155. Clear?
Yes,
Yes,
sir.
sir.
So you can find out this for QI2, phi I2 and QI2, and you can find out for phi I3 and QI3. Clear? Just using these two, this formula and this formula. तो difficult नहीं है समझना? Yes.
Yes, sir.
Now what is this VI1? Now this is the lateral force. Let me show you through the graph so you will understand. So now this, that is Q41, that is 155. Okay, this is my another force which is Q31. Then this will be Q21, which is this, and finally you will see that this is your Q11. Clear over?
Yes, sir.
Now this is called a design lateral force at terrace level. This is design lateral force at third floor. This is design lateral force at second floor, and this is design lateral force at first floor. So these are external loads that are being created due to the movement of earthquake, due to the movement of ground or shaking of ground because of earthquake. क्लियर हुआ कि नहीं?
Yes, sir.
Clear है sir.
Okay. Now, see, again, I am saying that this earthquake has not carrying any force. Earthquake is not carrying any force. Earthquake is carrying energy, and it is giving energy to the base, and because of that, base is vibrating. And because of this vibration in the base, these forces are generated at floor where mass is concentrated. Clear?
Yes, sir.
Sir.
Are the now they have to be registered. So I'm registering it over here, and I'm calling it as QV41. So what is the value of V41? Q41. Yes or no?
Yes, sir.
Now, if I want to register it at this floor, I will call it as V31. And what is the value for V31?
Q31.
यही तो गड़बड़ है. It is 41 plus 31. अब आया समझ में?
Yes,
ये
sir.
दोनों को रजिस्टर करना पड़ेगा ना ये लेवल पे.
Yes, sir.
सिर्फ इसका रजिस्टर करेंगे, फिर इसका क्या करेंगे?
Right, sir.
What is the equation? So at this floor, if I want this floor intact, then I have to make this column strong enough to resist both. Clear हो रहा है?
Yes, sir.
So that is how it is calculated.
Yes, sir.
At terrace, it is 155. At lower floor, this plus this provided over here. At this floor, this plus this provided over here. And at ground or at first floor, this plus this provided over here. अब देखो है कि नहीं? 155 is written over here. 155 plus 1
96.
352 plus 8 plus 96 is written over here.
Yes, sir.
Clear? So this is for mode number 1. The same thing will be for mode number 2 and same thing for mode number 3. And exactly that is what I was trying to show you. I said that I will talk to this later on. Right?
Yes, sir.
So story shear forces due to all modes considered. See, यहां तक लोगों को समझ में आता है बहुत सारे, और फिर यहाँ पे वो दे रहे ये VI क्या है? VI कुछ नहीं. अगर आप ग्राफिकली रिप्रेजेंट करोगे तो मैं कहूँगा दिस प्लस दिस प्लस दिस प्लस दिस. तो ये मेरा QI है. ओके.
Yes, sir.
QIK. तो यहाँ पे क्या होगा? दिस प्लस दिस, तो टोटल कितना होगा? इतना. यहाँ पे कितना होगा? ये QI3 है, तो ये और ये टोटल कितना होगा? इतना. यहाँ पे कितना होगा? टोटल इतना. और यहाँ पे कितना होगा? ये प्लस वो उतना ही है, ग्राउंड. So this is how you can find out, and that is what this story shear. So what is the difference between design lateral force and story shear? It is nothing but it is a shear to be registered at that story. So at terrace, design lateral force and story shear will be same. At below, it will be a sum of all stories above that story. Clear हो रहा है?
Yes, sir.
Yes, sir.
And उसका रिवर्स करेंगे तो I can say that Fi is Vi minus Vi plus 1. उसका ही रिवर्स करके देखना, आपको ध्यान में आएगा. वो कुछ बहुत बड़ा इश्यू नहीं है. थोड़ा थोड़ा इनिशियली कंफ्यूजन हो सकता है, बट so once you find Qi and then you find Vi for every over here, this will be here, this will be here, and this will be here. Now this is for mode number 1, this is for mode number 2, this is for mode number 3. Now these are the forces that are to be registered, maximum forces that are to be registered at that story level under 3 different modes. तो आप डिजाइन किसको करोगे? थोड़ा प्रॉब्लम है. आप डिजाइन एक ही फोर्स को करेंगे ना?
Yes, sir.
You will not say that no, okay, my building will not be subjected to mode number 2, mode number 3, so I will design only for mode number 1. और मोड नंबर 2 को वाइब्रेट होने लगी तो फिर यू डोंट नो व्हाट इज हैपनिंग. अच्छा बुरा पता नहीं है ना, क्योंकि हमने डिजाइन ही नहीं किया. तो अगर ये तीनों को कंबाइन करना पड़ेगा तो कुछ करना पड़ेगा. वो क्या है आगे देखते हैं. Now you can see I will say that this Vi1 is the maximum force that I must design mode number 1. So this, if the building is subjected to mode number 2, this is the maximum, and if the building is subjected to mode number 3, this is the maximum. So one can say that if you want average of that or highest, डिजाइन करोगे तो कभी सेफ होगा कभी अनसेफ होगा. We do not want both. So mathematicians have found, because see, mode number 1 is occurring at some different stage, mode number 2 is occurring at some different time, and mode number 3 is also occurring at some another time. They are not giving you deformation at one time. Under different time, the building might be subjected to different modes, and we have to design the building which will be safe for all modes. So code or mathematicians, not code, code has taken the help of mathematicians, and mathematicians say that when the probability occurrence is different at different time and still you want to find out the safe result or representative sample that can be calculated with the help of square root of sum of squares. See, the contribution of different modes is combined by the SRSS, square root of sum of squares method. Now, this method has been defined and successfully they have given the proofs for that. And if anybody wants to challenge this, then he will have to study the theory of probability and lot of deviation and then all the statics and probability. So a wise person will say that अरे उन लोगों ने सब define किया है ना, तो we'll take the result and we'll do the thing, because we are engineers, we are not mathematicians, so we'll follow what mathematicians say. So mathematicians say that if you want to find one representative sample, that means, see, these are the 3 samples and you are getting a value at terrace level, this, and this, but you're not sure or you want a shape design, then you can square the values, then get the summation, and final summation will be square root. So that's why square root, square root of sum of squares. So individual quantity को square करो. So this is for mode number 1, mode number 2, mode number 3. They are squared individually and the square value is summed, and that summation is then found out with square root. So square root of sum of squares. Clear हुआ?
Yes, sir.
Yes, sir.
Okay, so this is the very well known formula, and if some of one has done some study in probability and analysis, probabilistic analysis, so they are using this formula, the same formula we are using, and we are finding the result as 182 will be the effective force at roof level, V4, right?
Yes, sir.
So what I am doing, I am calculating, I am squaring this, I am squaring this, and I am squaring this, and then summing all the squares and finding out square root of that summation. The same thing will be carried for all floors. For V3, so you can see 352.3 squared, 115.6 squared, and 5.2 has been squared. Then it has been added, and that addition is found with square root. So finally, you will see that 371. Now you can see that, sir, यहाँ पे तो माइनस है, आपने तो लिया नहीं, यहाँ पे भी माइनस है, तो गलत हुआ कि नहीं हुआ?
सर स्क्वायर रूट है तो फिर
स्क्वायर करने से
स्क्वायर की
पॉजिटिव है।
वजह से सर वो
So even if
पॉजिटिव
you say minus, then square will be positive. That's why it is not shown over here. So you can see that square root of sum of squares will give you these representative lateral forces that might be, the building might be subjected, and these are our design design story shear. Okay, because V is story shear, right? It is not Q. Q is a lateral force at every floor, while V is a design story shear. Clear?
यस सर
तो यही तो हमने इक्विवेलेंट स्टैटिक लोड मेथड में निकाला था, मगर वहां आंसर अलग आया था. अब देखते हैं. अब मान लो यहाँ पे क्या करेंगे. इफ आई वांट टू सी द बेस्ट शेयर, हाउ मच विल बी द बेस्ट शेयर? दिस 610.
Yes, sir.
Clear?
यस सर
क्लियर सर.
Because you are having it, you are having a story shear which is this, and this. So this is my base shear. Let's say it is acting in this direction. So VB bar, I will call this as VB bar just to differentiate from base shear that I have calculated with the help of equivalent static. अब main twist यहाँ होता है. Just try to see, and if you can understand this, then I will see that now you are perfectly prepared. अब यहाँ देखो. This clause 7.8.2 from IS 1893 says that whatever base shear that you have calculated, that is base shear obtained by dynamic analysis. In our case, it is 610, be compared with that obtained from empirical fundamental period as per clause 7.6. That means equivalent static load method. Now, if the base shear or VB is less than that of empirical value, the response quantities are to be scaled up. अब ये समझ में नहीं आया. This is called scale factor. आपने वो देखा था ना, मैंने बोला था दिस आई विल टॉक टू यू अ बिट लेटर.
Yes, sir.
What was that? The scale factor. Now this,
Scale factor,
yeah,
yes.
now this is the time. This is the time. अब इसका मतलब क्या है? That means even if you, the first thing is that, or first impression is that, or I will say first inference that I have calculated is that even if I am going for dynamic analysis, calculation of base shear with the help of equivalent static load is a must. अगर वो नहीं किया तो कैसे पता चलेगा वो कम है ज्यादा है? तो करना पड़ेगा,
Yes.
right?
Yes, sir.
So the first thing is that you cannot neglect the equivalent static load method. Equivalent static load method. ये आपको करना ही है, आप कितना भी डायनेमिक एनालिसिस कर लो. You have to find out VB. ओके, हमने निकाला, वो आया था हमारा 1404 किलो न्यूटन. आई एम नॉट राइटिंग दैट. देन you are going for dynamic analysis with the help of response spectrum analysis and modal superposition theorem, etc., and you will find out base shear that we have found out as 610. अब आपको ये कंपेयर करना पड़ेगा. अब कंपेयर क्या करना है? कंपेयर क्या करना है कि वेदर वीबी बार इज लेस देन वीबी, and which is always, most of the time, 99 out of 100, you will see that VB bar, which is a dynamic base shear obtained by modal superposition or response spectra, whatever you say, will be less than VB. And if VB is less than, okay, so here we will have to call this as VB bar, because this is VB bar that I'm calling for dynamic base shear, and VB is static base shear. That means if the dynamic base shear is less than static base shear, then response quantities are to be scaled up. हो गया ना जमेला?
Yes, sir.
फिर वही आए. अब पहले तो पता चलेगा ये व्हाट इज दिस रिस्पांस क्वांटिटी, और दे, ठीक है, वो स्केल्ड अप करेंगे. बट व्हाट इज दिस रिस्पांस क्वांटिटीज? दीज आर नथिंग बट the lateral or story shear forces that you have calculated with the help of this. So these are your response quantities, or I will say, well, so I will say these are your response quantities, or let's say this. So these are your response quantities. So these are your response quantities. That is Q, I1, I2, I3, I4, whatever it is, or moment, or shear, whatever that. Because why it is called response quantities? Because these are the response given by the structure to the earthquake dynamic, earthquake motion. अगर ये earthquake नहीं आता तो ये भी नहीं आते ना.
Yes, sir.
That's why they are called as response quantities. Clear? चलो, उतना तो समझा कि नहीं समझा?
Yes,
समझ
sir.
गया.
Yes, sir.
So response quantities, now they are to be scaled up. तो scaled up करना है यानी क्या करना है? and with what scale, that we'll see. See here. Now here, instead of this V4, what we are calculating? We are calculating Q4. Again, it is Q4 will be equal to V4. Then Q3 will be V3 minus V4. So this is my Q4, and this is my
Q3.
Q3 plus Q4. So I can say that if I say here V3, let's say V3, and here V4. Okay,
Yes, sir.
and I can say that this will be equal to
Q4.
Q3 plus Q4. That means what is Q3, which is equal to V3 minus V4. See, V3 is this much and V4 is this much. So Q3 will be V4 minus
V4.
V3 minus V4. Yes.
Yes, sir.
Similarly, Q2 will be V2 minus V3 because this is your V2 and this much is your
Q2.
Q2.
Yes, sir.
So V2 minus V3 and Q1 will be V1 minus V2. So this is your V1 and only this much is your Q1. Clear?
Yes, sir.
Yes, sir.
Now, अब आपको response quantities मिला. How it has been calculated with the help of V3, V4, and V2, V1.
Yes.
Yes, sir.
अब क्वेश्चन है कि डायरेक्टली यहां से क्यों नहीं लिया. फिर आपको अलग अलग मोड वो मिलता था ना, रिप्रेजेंटेटिव नहीं मिलता था. ऑलरेडी यू हैव फाउंड आउट रिप्रेजेंटेटिव इन टर्म्स ऑफ स्टोरी शेयर. तो वहां से आप रिप्रेजेंटेटिव फॉर एवरी फ्लोर यू कैन फाइंड आउट. क्लियर?
Yes, sir.
So finally you will say that Q1, which is 100 kilonewton, is one representative value that the building is subjected to as a lateral force at floor number 1 for all modes. Because now it is a representative sample of mode 1, mode 2, mode 3.
Yes, sir.
So 100, 139, 189, and 182 are your final response quantities that you have calculated with the help of dynamic analysis. Now these response quantities are to be scaled up. That means they are to be increased by some scale factor, and that scale factor is calculated over here. See, we calculate base shear as per clause 7.5.3. This was done in previous example, and that was 1404. Clear? So equivalent static load. Now we have carried out dynamic analysis, and the base shear that was calculated by dynamic analysis was 610, which is lower. Hence, the response quantities are to be scaled up in the ratio of equivalent static base shear divided by dynamic base shear. So what is the ratio? 2.3. So every response quantity will be scaled up by 2.3. Clear हुआ?
Yes, sir.
Yes, sir.
Clear, sir.
Okay, ये clear तो हुआ, मगर इसका meaning क्या है? And why it is required? Again, I'm talking about this, and I might talk about this for half an hour, but I will try to shorten it. But you think, see, what is the necessity of calculating? एक तो पहले क्या है कि you in one say you say that equivalent static load method cannot be reliable because it is approximate. It is having n number of approximations. So, and when the building is having irregularities or complex shape or all that n numbers, then you cannot base uh, calculation static analysis. That means वो इक्विवेलेंट स्टैटिक एनालिसिस मेथड पर ज्यादा भरोसा नहीं कर सकते, तो उसके लिए कोड ने आपको क्या बताया? सो यू हैव टू गो फॉर डायनेमिक एनालिसिस. सो यू कैरीड द डायनेमिक एनालिसिस. चलो वो भी ठीक है. अब डायनेमिक एनालिसिस कैरी करने के बाद कोड क्या बोलता है? अब वो रिजल्ट वो पहले वाले के साथ कंपेयर करो, और अगर नया रिजल्ट पहले वाले से कम है तो उसको स्केल्ड अप करो. अब ये क्या चक्कर है ना बड़ा?
राइट सर.
यस,
राइट सर.
ना उसका रीजन ढूंढना है. मैंने जिन जिन लोग तो सब बहुत सारे लोगों को या नोबडी कुड आंसर मी. मैंने बहुत सारे किताबों में पढ़ने की कोशिश की, मुझे ये नहीं समझ आता अब क्या है. एक बार ये बोलते हैं वो अप्रोक्सीमेट, फिर बोलते हो डिटेल करो, डिटेल करने के बाद बोलते उसके साथ कंपेयर करो. तो फिर डिटेल करने की जरूरत ही नहीं ना, पहले वाला ही रिजल्ट ले रहा हूँ ना मैं. बराबर है ना?
यस सर.
यस.
इट साउंड्स क्लियर. अगर सिस्टमैटिकली हम बात करेंगे तो वही है ना. डिटेल करने के बाद आप बोलते हैं नहीं नहीं, अब वो जो डिटेल एनालिसिस आपने किया है विद द हेल्प ऑफ गुड एफर्ट्स एंड लॉट ऑफ डायनेमिक स्टडीज एंड क्या क्या पता नहीं, मॉडल मास निकालो, पार्टिसिपेशन फैक्टर निकालो, क्या क्या नहीं करना पड़ा, इतना करने के बाद बोलते अब इसके साथ कंपेयर करो. फिर क्या चक्कर है? Okay, I will try to. There are n number of reasons, or most of the time people say that okay वो कोड वालों ने बताया तो कर देते हैं ना, हमको क्या है 2.3 से मल्टीप्लाई करना है तो कर देते हैं, चलो छोड़ो. ये भी एक रीजन यू कैन से. बट लेट मी टेल यू अ बेसिक डिफरेंस. प्रोसीजर में जाओ. ये आपका बिल्डिंग था. ये बिल्डिंग को आपने क्या किया? इक्विवेलेंट स्टैटिक मेथड में ये जो अर्थक्वेक का एनर्जी अप्लाई हुआ उसकी वजह से पहले आपने क्या किया? आपने वीबी निकाला. बराबर?
यस सर.
पहले हमने वीबी निकाला ना.
यस सर.
और उसके बाद ये वीबी को सम assumed distribution shape, maybe linear, maybe the parabolic, maybe anything between, वो भी assumed. So इसको हमने ये हेल्प ऑफ अर्थक्वेक एनालिसिस जो डाटा है with the help of रिस्पांस स्पेक्ट्रा, वो जो डिजाइन रिस्पांस स्पेक्ट्रा वगैरह कोड ने दिया है उसकी मदद लेके हमने ये कंक्लूड किया कि द अर्थ इज गोइंग टू मूव और द बेस ऑफ दिस बिल्डिंग इज गोइंग टू मूव, एंड बिकॉज ऑफ दैट दिस विल बी द मैक्सिमम फोर्स दैट कुड दिस बिल्डिंग में नीड टू सस्टेन. क्लियर? और फिर ये हमने यहाँ पे डिस्ट्रीब्यूट किया, ऐसा ही किया ना. फिर हमने V1 निकाला, V2 निकाला, V3 निकाला, वो था ना वो कुछ ऐसा.
यस सर.
WI HI स्क्वायर डिवाइडेड बाय ये WI HI स्क्वायर डिवाइडेड बाय सिग्मा WI HI स्क्वायर. मल्टीप्लाइड बाय वीबी, या ऐसा कुछ निकाला ना हमने।
यस सर।
मतलब पहले ये निकाला और फिर यहाँ पे डिस्ट्रीब्यूट किया, and this distribution was assumed to be parabolic because we have assumed hi equal to 2 और hi raised to 2। अगर ये 3 होता था तो क्यूबिक होता था, 1 होता था तो लीनियर होता था, ये मैंने बात किया था, राइट। सो दिस वाज assumption and this was the calculation। अब इसमें बिल्डिंग का कोई कैरेक्टर आपने डिफाइन किया नहीं किया, ओके, क्लियर हो रहा पहला।
यस सर।
अब दूसरे में हमने क्या किया, दूसरे में हमने बोला नहीं यार, वो पहले में तो हमने वो बिल्डिंग का कैरेक्टर देखा ही नहीं, एज्यूम किया फंडामेंटल टाइम पीरियड। अब दूसरे में हमने क्या किया, बिल्डिंग को डायनेमिक कैरेक्टर से डिफाइन किया और एवरी फ्लोर पे प्रोबेबल लैटरल फोर्सेस डिफाइन किए, बराबर। और सबका सम करके यहां पे हमने सिग्मा ये लिखा और उसको बोला वीबी बार। क्लियर हो रहे?
यस सर।
पहले इधर से इधर गए और दूसरे में उधर से इधर आए। तो पहले में कैलकुलेशन वाज बेशियर, वीबी was calculated with respect to earthquake analysis, and second में VB was calculated or VB bar was calculated with actual character of the building and then summed up, right?
Right sir.
Now both methods are good enough to indicate the behavior. Both methods are having approximations in there. Nobody is perfect, okay? पहले में हमने अर्थक्वेक एनालिसिस के भरोसे कुछ बेस ईयर निकाला, दूसरे में बिल्डिंग के बिहेवियर कैरेक्टर प्री वाइब्रेशन एनालिसिस से रिजल्ट्स निकाले और स्केल्ड अप किए, सम अप किए। नाउ कोड से दैट ये भी इंडिकेट करता है कुछ, ऐसे नहीं कि इसको पूरा इग्नोर करें। एंड ये जो निकाला है दैट इज एक्चुअल कैलकुलेशन ऑफ विथ रिस्पेक्ट टू dynamic analysis, but we cannot neglect anybody, so at least whatever this calculation, so पहले में जो अच्छा था वो कलेक्ट करते हैं, दूसरे में जो अच्छा था वो कलेक्ट करते हैं, and we'll see that with this अगर response quantities को अगर scaled up किया, so we will get another fine which will have benefit of both. Clear?
Yes, sir.
Sir, but the summation of this also is equal to 1404, na? In static we have assumed, na? And for dynamic we have calculated
610.
Yes, sir. So then also by adding this factor, the total becomes that previous one.
But the procedure is different. That is what I am trying to say. पहले हमने 1404 निकाला विथ assumed डिस्ट्रीब्यूशन, उसको डिस्ट्रीब्यूट किया, और सेकंड में हमने एक्चुअल कैरेक्टर को काउंट करके लैटरल फोर्स से डिफाइन किए और उसका सम अप करके बेस ईयर निकाला। क्लियर हो रहा है?
यस सर।
अब दोनों में अगर ये डायनेमिक एनालिसिस का बेस ईयर इससे भी ज्यादा होता था तो कोई प्रॉब्लम नहीं, मगर इससे कम है, तो in that case or says that you should not ignore that value. So better is that you see this is due to actual behavior of the building, considering the character of the building, dynamic character of the building, and this is could be the maximum lateral base vibration. So this is also correct. That's why what you do, find out the ratio and scaled up every value that is in dynamic analysis by this scaled factor, so that you will get a safe distribution. So this is how this clause, why this clause 7.5.3, it is actually uh, giving you uh, a safe, because this base shear is your design base shear. If you see, actually uh, that design base shear is calculated something like this: ah into total seismic weight, and this ah is calculated with some different values: z by 2, esa by z, divided by r by I. यहाँ पे R हमने लिया ही है because this is design based shear and not maximum considered base shear. अगर वो maximum considered base shear का calculation में we are going for reduced response we are designing for lesser value of base shear. So इसमें इतनी ऑलरेडी हमने रिस्क उठाई है, तो और ज्यादा रिस्क उठाने की जरूरत नहीं. सो इट इज ऑलवेज बेटर टू डिवाइड दिस by this, find out the scale factor and multiply all these response quantities with this scale scaled up factor. So scale factor, so this is called a scale factor. So this will ensure that under any circumstances your building is not going to resist lesser uh, lesser lateral forces under minor earthquake or moderate earthquake. थोड़ा थोड़ा कॉम्प्लिकेटेड है, आपको जरा जितना ज्यादा उस पर काम करोगे उतना ज्यादा समझेगा. बट एटलीस्ट आई हैव गिवन यू द कंसेप्ट, बिकॉज मेनी पीपल से दैट ये कोड कुछ भी बोलते हैं, एक बार ये बोलते हैं, एक बार वो बोलते हैं, फिर बोलते हैं स्केल अप करो, कुछ भी ऐसा नहीं है. It has, see the probability, see again I am saying we are talking with probability. Nobody knows actual base shear that the ground might be subjected, right? Nobody knows, not even Japanese. So they also go with this scaled up quantities. ऐसा नहीं है कि इंडियन कोड नहीं किया है. एवरी इंटरनेशनल स्टैंडर्ड्स दे आर गोइंग फॉर. हाँ, मे बी थोड़ा थोड़ा बहुत अलग है उनमें, थोड़ा बहुत उन्होंने वो इसको स्केल फैक्टर को कम करने की कोशिश की है, बट दैट डिपेंड्स ऑन देयर क्वालिटी कंस्ट्रक्शन, वॉट एवर दैट दे आर हैविंग. वी सी आवर कोड हैज defined all this with our conditions. So our code says that you have to find out the scale factor 1404 divided by 610, or I will say that a static base shear divided by dynamic base shear, whatever is the factor, you have to scaled up all your dynamic uh, response quantities by that factor. Clear?
Yes, sir.
Yes, sir.
So this is how you can go ahead, and now you will see in picture what is the meaning, why it is given by the code. You can see here. So this is your static calculations, which are saying 79 to 97 504 611, and you can see the variation. Okay, now if you see dynamic scaled up quantities, so these are your dynamic scaled up quantities. So if you go for story shear, you will see over here how it is changing, and you can check it over here. So this is a dynamic scaled story shear is more more reliable, and that you can see over here. See, this is your lateral forces due to equivalent static analysis, how it is making. And here you can see that it has been in a uniform. Now this into actual behavior with scaled up quantities.
Yes, sir.
Clear? So this way you can go ahead, and now I think I will stop over here. ये dose काफी बड़ा होता है, so it is better. Actually, in next session, I wanted to apply all these in our ETAB, but there is a little bit change because of that loss of one session that was because of no light connection at my थोड़ा तो 3-4 session will be conducted by Anil sir, and then we'll come to this ETAB again. And now whatever we have learned in PPT will apply directly into our ETAB model, and we'll create equivalent static analysis. We'll see how it is simple in ETAB. We will also go for dynamic analysis, and then we'll see the results in ETAB. So all that actually I was going to carry out in continuation, but right now you will go for first design of columns, beams, slabs, and footings with the help of Excel sheet, and then we'll come back in our ETAB model, and we'll find out the results for the lateral loads also. Okay.
Okay, sir.
Yes, sir.
Yeah. But that will be again, it will be a beneficiary to you also. The only thing is that those 4 or 5 sessions will be conducted by Anil Mahadik sir, and then again the control will be given in my hand, and we'll continue our course again. एक ही आदमी के सेशन देख देख के आप भी बोर होते हैं ना?
नो सर।
नो
No,
सर।
sir.
No, sir.
नहीं हो रहे?
किसने बोला सर ये बात आपसे?
मैं बोल रहा हूँ ना, किसी और को बोलने की जरूरत नहीं। नॉर्मली होता है ना, नॉर्मली होता है ना, क्या है
सर आप जितना पढ़ा देता तो मैं एमटेक में भी नहीं पढ़ा हूँ।
नहीं
अब
नहीं,
मुझे
ये बात
मुझे फिर से देखना पड़ेगा। आज रात से मैं इसको स्टार्ट करूंगा।
हाँ, देख लो अच्छा है। You will get a time for your studies also, but go ahead with that, and then afterwards again we'll come back in model, and we'll see all these. See here, I have not shown you that free vibration analysis, but then we'll carry out that free vibration analysis with the help of ETAB, and then we'll see all those deformed shapes, that mode number 1, mode number 2, mode number 3, all that we'll see in a picture. तो मजा आएगा. Okay, any query if you are having, you can please go ahead with the query. See, lateral load analysis, either it is with the equivalent static or with the dynamic analysis. Unfortunately, there are no enough sessions on YouTube also, और जो है वो इतने हाई लेवल पे है कि समझना मुश्किल होता है. So that's why we have started this. Actually, though we are supposed to train you for software analysis, but वो mechanical without understanding कुछ करना उसका कुछ मजा नहीं है. So we have focused on conceptual thought, behind the software, and then you can use the software so that you will be in better control. And I think we are doing on the right side.
Yes, sir.
या बट आप लोगों को भी उसका एक्सरसाइज करके प्रैक्टिस करके हमारे एफर्ट्स को रिजल्ट्स में लाना है. अगर यू पीपल विल नॉट गो विद दिस सेशन देन ये वन साइडेड होगा. But I think you people, lot of people from your batch, they are interested. At least अविनाश हो या समीर या मसरूर जहान. मैं बाकी लोगों को भी या सुलेखा मैडम is also asking sometimes, but I will say that you should open up yourself and carry out your doubts so that we'll also be able to help you.
सर सिर्फ संडे टाइम मिलता है कुछ भी ऐसे रिवाइज करने के लिए. वीकडेज में कुछ भी नहीं मिलता है सर.
नहीं फिर see how you can find time.
मैं तो बहुत पीछे हूँ सर. अभी मैं खुद से शुरू कर रही हूँ, बहुत पीछे हूँ और क्लास बहुत आगे है सर. यही प्रॉब्लम है. तो बट थोड़ा कर रही हूँ. But
you can exercise in the night also. See, the same problem I was facing because when I started learning all these things, I was already in job, and I was a construction engineer on a site, and I was holding a senior position. So मेरा बहुत समय वहाँ पे जाता था. So I used to work late night. मैं रात को 1-2 बजे उठकर वो करता था. See, it is your problem and you can only find a solution on it, no one else.
Sir.
Right?
Yes, sir.
Yeah. See, if you focus on a problem, you will get a problem, and if you focus on a solution, you will get a solution. ये भगवान का लॉ है. पता नहीं ये ऐसा क्यों है. भगवान बोलते आप जो चाहे वही मिलेगा, और हम बोलते यार भगवान बहुत प्रॉब्लम है. वो बोलते अच्छा और ले ले. आपको कहना पड़ेगा यस देयर इज अ सॉल्यूशन. भगवान बोलेंगे और ले ले. समझ में आ रहा है ना ट्रिक. यस अविनाश बराबर है ना
सर.
सी हम लोग जो सोचते हैं ना वही सत्य में आता है. अगर हम लोग प्रॉब्लम के बारे में सोचेंगे ना तो हमारे सामने प्रॉब्लम्स ही आएंगे. अगर हम सॉल्यूशन के बारे में सोचना शुरू करेंगे तो हमारे सामने सॉल्यूशन आएंगे, क्योंकि ये भगवान का रूल है और इट अप्लाइज टू एवरीबॉडी. So if you think of the problem, and problem will come in front of you, and if you think of the solution, then solution will come in front of you. So it's a choice. It's not a destiny. It's a choice. And unfortunately, as we are not aware of this law, we go for wrong choice, and we say that don't focus on a problem, focus on a solution. See, हर किसी को प्रॉब्लम है, मुझे भी प्रॉब्लम है, but I don't focus on a problem, I focus on a solution. You will not find anybody in this world who does not have a problem. अगर कोई ऐसा है तो मुझे बताइए. Even Prime Minister Narendra Modi is also having a problem, but why he is success? Why he is getting success? Because he is focusing on a solution. समझ में आ रहा है ना. कोरोना आने के बाद सारी दुनिया सॉल्यूशन नहीं निकाल पाई, मोदी साहब ने निकाला. क्यों? फ्रॉम डे वन ही वाज फोकसिंग ऑन अ सॉल्यूशन and entire world was focusing on a problem. Yes, sir. So see, See, I'm not criticizing anybody. I just want to show you this rule, क्योंकि ये rule मुझे बहुत लेट समझा, something around at the age of 40. मैं आपको ये rule at the age of 20, 25, 30 में बता रहा हूँ, तो आपको ज्यादा एडवांटेज मिलेगा अगर आप ये रूल को सही ढंग से अपने लाइफ में अप्लाई करेंगे. You focus on a thing and that thing will happen in your life.
Yes, sir.
Yes, I
Excuse me, sir.
100% agree. I 100% agree with what you are saying, because there is nobody who has no problem. So you are also having a problem. I 100% agree with you. But I'm just trying to suggest that don't focus on a problem, focus on a solution. तो बाद में आपको solution मिलेगा. I hope all of you can start thinking like that. Yes.
Yes, sir.
Yes, sir.
And देखो दुनिया कैसी आपकी बदलेगी, जैसे एटीट्यूड आपका बदलेगा ना, तो you will find now everything is going smoothly. Anyway, that is not a technical, but that is very important. That attitude. See, majority of people face failure because they don't have this particular attitude. Only that is the thing. ऐसा नहीं है कि कुछ जो सक्सेसफुल हो गए वो बहुत बड़े इंटेलिजेंट थे, ऐसा कुछ नहीं है. They are focusing properly, that's why they are getting the results, and others who are not getting the results, they just have to change their focus, that's all. उसके बाद उनको भी मिलेगा. Okay, with this I will conclude today's session.
Sir,
Yeah.
excuse me, sir.
Yes.
Sir, in that PPT, in the last one, that red color glowing, no, in that why it 415 is coming in the roof and 435 is coming in the third floor in response spectrum.
Actually, see, there is actually in the, if you see that, okay, that is you can see this. Q static 611, 504, 297, and 79. These are the static loads at floor 1, 2, 3, 4, and due to equivalent static load method. And these are the scaled up quantities. So you just have to see the scaled up quantities. So this is, see here it is 189 and here it is 182. That's why it is going like that.
So the picture should not come like that, no? It should be
No.
away from.
No. See what I'm trying to show you here is that this is the actual behavior of the dynamic analysis, which is subjected to, because here you have gone through the dynamic characters of the building. You just want to see that this 320 is more than 230 and 435 is more than 320, then this 419 should be more than 435. That is what you want to say,
Okay, sir.
right? No, but that is depending on this. See here you are getting Q1 as 100, then Q2 as 139, Q3 as 189, and this Q4 as 182. This is less. This is the Q4 is less than Q3, and that's why you are getting this result. So actually, if you want to check the entire thing, you will have to see this. So this you will have to see this, or You will have to go. See, you will have to find this. Actually, you will have to find this, and based on that, actually, it is to be checked. Whatever you are saying is right.
Okay, sir. Okay, that's why I thought maybe this only for
Or
this
maybe,
problem or
actually, this may be a calculation mistake that has been carried out for calculation of this 182, and that will be reflected over here. See, we have to check this.
okay,
Okay,
sir.
yeah, I will go with this by actual calculation, and then I can say that. But rightly, you have pointed out that this normally this 419 has to be more than 435, or
Yes, sir.
you may say if this is 419, then this has to be less than this, maybe 400. That is okay.
Yes.
So that is to be checked. You are 100% right.
Okay, sir.
Okay, I will check it and will correct this PPT if there is a mistake. Uh, or
Okay, sir.
you can check it over here also. You can check it with this. So all these calculations you have to find out, and you can check it this.
Yes, sir. Will do.
Only this one and this one is to be checked mathematically, and there might be some mistake. Yes, you're right, 100%. I will go through that.
Okay, sir. Okay, just I felt doubt. That's why I asked you.
No, no, that is okay. That is okay. Definitely. And see, if something is I also do not understand, then I will say that I will have to go through that. I'm not going to overrule whatever you are saying. So that is what I expect from all of you. क्योंकि हो सकता है उसमें भी गलती है. Actually, I have not gone through entire calculations of the PPT, but now I will go through the calculation part also, because most of the time I concentrate on the concept rather than magnitude. मेरे लिए वो magnitude बहुत अफेक्ट नहीं करता है अगर प्रोसीजर सही है, उसके पीछे का साइकोलॉजी सही है, उसके पीछे का अंडरस्टैंडिंग क्लियर है.
Actually, I didn't check the values, sir. Just I go through the picture. Then I thought how it is going inside. Should be outside if it is 435. That's why
यस
I
यस
asked.
यस, योर डाउट इज 100% करेक्ट. वो शायद मेरी समझ में भी आना चाहिए था, जो नहीं आया. ओके, बट दैट्स व्हाई आई सेड यू आर 100% राइट. Prima facie it looks something different, but I will go through that and will correct it, and if it is corrected then we'll share you that. Don't worry about it.
Okay, sir.
See, this is how you should start thinking. One should not believe everything blindly. हो सकता है आपका आपका सोचना गलत है, मगर पता तो चलेगा ना कि गलत है. अब जैसे मैडम ने पूछा तो व्हेन आई वेंट इनटू इट, यस डेफिनेटली मुझे भी वही लग रहा है कि
Sir, please don't call me madam this time.
no, see, it is always better to respect others. That is what I say. Everybody. So for me, everybody is respected. Okay. So with this, okay, one more thing. If you go through the entire PPT, that equivalent static load method as well as that response spectrum method, you go through that. And if you have any query anytime afterwards, you can ask me. So with this, I will conclude. Okay. Hello.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Good night, sir.
Thank you.
Good night. Good night.
Good
Good
night.
night. Yeah. Good night.
Thank you, sir. Good night, sir.
Good night.